lecture, inshallah. Yeah. Okay, this one. When you do the balancing typically on the wheel, for example, when you run the wheel, you rotate the wheel a bit, then you will find that this one is the you will have two spots. One will be the lighter spot, the other one the heavier spot. The lighter spot will always at the top, the heavier spot will always at the bottoms. Okay, this one, yeah, heavier spot and lighter spot. You can read this one on your own. Okay, then the first thing that I discussed earlier just now is basically on plane. If you have so many mini plane, for example, you will have what? You will have a moment. So this time around, you are applying the same thing as what we did earlier. And this one we've done earlier. Look at here, did resolve the equation. You have how many blade? 3 blade. Not very, yeah. One, yeah. 1, 2, 3. 3, what? 3 term of equation. So supposing you have 100 of blade, then you have 100 of, you will have one equation, correct? But you have 100 of term of equation. It's very, very messy in your calculation. Huh? And you resolve it into x and y, you'll be getting as such this one to x, this one to y, then with the resultant. Again, if this one is not equal to 0, you have to add a system, add a mass to the system. Yeah? This one is in practical, as I mentioned earlier. I'm not going to do this one. This one is, as already mentioned earlier, when you found that it is not balanced. So these are the thing what you call balancer to put on the wheel, alloy wheel, whether it will be put an adhesive to ensure that it will stick on the balancer without, fly when the car will be running with the higher speed, or it can be like what this one. This one is we have a pin here. This one, yeah, clip. Sorry, we have a clip here. This one with clip. This one is clip, yeah, with clip, C-L-I-P, with clip. This one is you put adhesive. It's the same thing basically. As long as it will not, the balance will not be moved or will not fly when the system or when the wheel is running or operating or rotating. Yeah, this one put adhesive here. Okay, this one is I did mention earlier about the principle of balancing. This is the principle of balancing. Yeah. Method, as I mentioned about method just now, is about analytical, which is very famous, and also graphical, which is very, easy to use because, it's easy to track where will be your errors, for example, or your, not correct calculation or constructing a polygon, for example. This one is a bit messy because if you have so many blade, for example, you work out the blade to be your term of equation, resolve to x and y, then you have to this simultaneous equation, where this one you constructing polygons. Constructing polygon is very much easy compared to analytical, but I'm not denying that analytically is also part of your method. But remember here, the graphical method can always be used when you are in class, okay, or you are in laboratory, but not in the actual thing. When you face the actual thing, you need to use the analyticals, because if you are good in analytical, you can also develop or make a software on it. You can use also what they call it, Excel, to develop the analyticals on balancing. You can do on your own, but don't do this one for the exam. Yeah, for the sake of knowledge. Dynamic balancing single plane, as I analytical method also be completed again. So this one is graphical. I'm going to explain to you more about graphical a bit. Constructing a vehicle is not very difficult. What you need to understand is you put everything in table. For example, yeah, the plane. Then you put mass. Of course, you have what do you call it? Consistent units. This one m in kg. Radius. The radius is measured, remember, from the center of rotation to the center mass of the body. Then you have the radius. You will have the mr here. You will have the mr here, and Also that you have the position. Okay, supposingly, yeah, you know everything this one. Okay, you know that everything you're calculating and giving, yes, this is all being given. So then you construct a polygon. This is the false polygon. Because why? You have to construct polygon. Remember, summation of m are equal to 0. What does 0 tell us? Balance. Okay, like the equation that been given earlier. So supposing this one, yeah, plane number 1 at theta equal to 1, and I'm assuming that this one is mine. This is what we call reference of position. This one sometimes given, sometimes it's not given. If it is not given, you have to use on your own, which is a standard one. You can put this one 90. You can also put this one 0, this one 90, 180. Put a 0 in this one. But please do not what do you call it? Very, very um, arts reference. For example, yeah, put here. It is correct, but not wise. Put it in 90, 80. It is correct, but not wise. Okay, this one is not standard. I'm not saying this one is not correct. Yeah, it is not wise. This one is standard one. Either 0 at top or 0 at left or right, which is x and y plane and in fact, yeah. Okay, if you have a starting point here, you have M1 R1. This is what you have, M1 R1, and it is 0 degrees, 0 degrees. This one must be in what? Excuse me, in scale. Okay, yesterday I've been talking 3 hours. I got lecture, so that is why I think my voice is not, healed, in good condition. Okay, anyway, M1 R1. The next one is M2 R2. Also, you also know this one division. For example, you have construct this one. You construct, and you measured 0 here because here is 0, horizontally 0. So then you have this one, you have this one. Then what? You close the polygon. So you have two possibilities. One, if this one is not closed polygon, it will fall or diverted a bit. So it is not balanced. So you have to close the polygon. You force to say to close the polygon because you applying this one. This one you have to add M. Of course with R, yeah, with R, which we call as unbalanced. This one, in another possibility, if you draw this one, and suddenly it's very fortunate that this one fall at the starting point. So this one is M R equal to 0 for the unbalanced. It's totally balanced. This one is not balanced. So you have two possibilities. In equation, perhaps you'll be getting what? The resultant will become 0. Either right, rather than you'll be getting some other magnitudes. In constructing polygon, you'll be getting a closed polygon. If the polygon is not closed, you have to force yourself to close the polygon. Because why? Because this is our boundary condition, saying that all MR must be equal to 0. Okay? Okay, now, I got question from student, yeah, a couple of every semester. They keep asking me about this one. This is my starting point just now. This is my arrow. This is my arrow. This one is my arrow. And suddenly, it is not balanced. Last point. Okay, now this is my starting point, and they asking me, so how you want to put the arrow? You have two possibilities. One is the arrow be pointing that way toward the center of toward to the point of starting point, or you can also close the polygon as this one, isn't it? So just start with the principle saying that summation of F equal to M1 R1 vector plus M2 R2 vector plus M3 R3 vector, isn't it? If you put this one, you have 1, 2, 3, 4, another one, M R4 also vector plus M unbalanced, R unbalanced that way. Correct, no? Because the same direction. But if you want to put this one is equal to all the same minus by M R unbalanced. The direction of normal equation is still correct. It is still correct. But when you do this one, the important thing is when we deal with force. We deal with force in bearing. This one I'm going to explain later on when we meet the topics. At the moment now, just follow the sequence of plus, plus, plus. Because why? Yeah, because when in constructing polygon, in polygon or in vector polygon, when you see plus here, is basically what? This one all plus, isn't it? This one arrow, head, tail, head, tail, all plus. When you have a negative here in polygons, yeah, what you mean? You mean that this one, head, head, or it could be also tail, tail. Okay, even though this one is simple, I know that everyone understands. So I just don't want you to keep asking me about the simple thing. Therefore, I explain here, then you know that, or you will capture the thing that you are studying in year one in vectors, polygon, in static, and also in dynamics. Okay. Okay, class. Hello. No one interested to respond. Yes, thank you, Ko. Thank you, Ko. Okay, now let us now move at dynamic balancing. When I say dynamic balancing, meaning that we are going to talk about forces. Just now we are talking about adjustment. Remember, we have two types. One will be the adjustment, the other one is forces. So dynamic balancing, it can also be one plane or so many plane. It doesn't matter. It can be one plane or so many plane. And for example, you're talking about multi-plane here. So in multi-plane, what you have is you have the additional force, which we call is no longer our aims, because we had done it earlier. But the other thing, when we are talking about multiplane, you have this one. Look at here. I make it bigger here, and I construct a big so that you can and this thing is rotating with omega. So this one you will have what? You will have M1 R1. Same thing as this one. You will have M3 R3. The other part also representing all forces. This one, yeah, you will have M2 R2. And you also have here M4 R4. M4. So this one is when you are dealing with multiplane. Okay. So when you have a multiplane here, you have to what? You have to check the reference. Select, it's not check, yeah, select reference. How to select? I will let you know later on. At the moment, now focus on how the equation generated. So how to set the reference, we're going to look later on. So supposingly now, I'm going to select this one as reference. Reference. Why I select one? I do not explain here. I will explain later on we meet the situation. I purposely select this one as a reference. So as this one is reference, this one, yeah, is this one becoming 0. Why 0? I also explain later on, not at this time. This one, the introduction. So we are going to do this one as a reference. So everyone will be what? Referred to 1. So you will have here D3, you will have D2, we have D4. Am I correct? Isn't it? So when this one multiplied by with D3, it becoming what? It becoming moment D. When this one multiplied by the distance of D4, it becoming moment 4. Same thing as this one, it becoming moment. Now you will have the moment. Okay, you will have the moment. So the moment now will be also look for the resultant and constructing or perhaps resolving into x and y, you'll be getting as such. And of course, when it is not balanced, you will have this one. If supposing that the system will be totally balanced, for example, what you might have is this one is equal to 0, this one also equal to 0. But very rare you find that the moment is 0. The moment will not become 0, so it is not balanced. Then you have to put mesh on the system, you have to remove mesh from the system, so on and so forth. Okay, so the only difference with single plane and multi-plane is for the single plane you have only one equation. For the multi-plane you have two equations, one coming from the force here, this one, and the other one coming from the couples, or sometimes we call moments, where the moment and couple is basically what? Basically force of the plane multiplied by the distance when you have the reference plane. How to select the reference plane, I'm going to talk that one later on when we have the problems. At the moment, if I talk the reference plane, how to select, it is not helping you anymore at the moment. Yeah, just remember that when you have multiple multi-plane, you need a reference one. You need a reference. Okay, graphical is the same thing. The only difference for graphical is you have another one. This one earlier you don't have this one, isn't it? So you have one from this one. You will have m r versus theta for forces. You have another one, MRD versus theta, you have moment or couple. Now you have two polygons. Just remember that you have two equations, you must have two polygons. One polygon representing all the forces, the other one representing all the moment or couple. And this is the boundary condition. The boundary condition. We assure that we have to ensure that this one becomes 0, this one becomes 0, because we want that the system is balanced or are balanced. Okay, further information you read in the books. Yeah, any question before we move to the example? Inshallah, we can complete one or two examples before we end our session today. Any question at the moment? Because after this, we're going to look for example number 1. Any question, I can answer any question related to this topic. Yeah. Yes, Lee. You like to ask any question, Lee? If you want to say something, you can on your mics. Yeah. Okay. Okay. No question. Thank you. I'm going to move to the next slide. You can turn to page 93, which is on your on your example number 1. I think you have a very enough what do you call it example to help you out in solving problems, typically in the book and also in other material or in other references that you have with you. Yeah. Okay. Can we start now? I'm going to open another file just to refer back from what you have in your hand, which is in your notes. Yeah, so that I can refer back this one. I try to I don't want to keep doing the same thing, copying back on the notes. I'm going to explain how the numbers come, and I'm going to help you by solving the tutorial problem rather than copy back whatever you have in your hand. No point of copy back. It will not helping you in your study. Yeah. So we'll start with example number 1. I'm going to, where are you? Example number 1. Yeah, this one. So that is the point why you buy the book. So easy for you to study. Yeah. It is not due to I make profit on the book. Yeah. If you see the books, it costs you only 30. How many ringgit? 40 ringgit, isn't it? 40 ringgit, I suppose. And if you compare to another book, you find that it's cheaper and cheaper compared to this one. Yeah. Even you buy dynamic, it costs you more, isn't it? Okay, anyway, if I can go back to this one, I'm not promoting my book class. I'm just saying that if you have the book with you, it's much easier in your study. Okay, you have this one. Okay, let us now read together this one. I'm explaining how do you extract the data. Yeah. So figures show 4 methods. This one, 2, 3, and 4 methods. This is how you you understand the equation. Yeah. Supported by 2 bearing. This one is 2 bearing and 2 bearing L and M, and fixed on a shaft. Fixed on shaft, correct? At constant speed of 1,000 sorry 100 rpm. Even though in equation, yeah, they do not mention, the question do not mention about constant speed, but you have in your mind then in balancing problem, the speed must be constant, even it is not mentioned in this equation. Okay, remember that. Okay, of course, yeah. Beyond that, beyond this, you have a coupling. This one you have coupling and coupling. Then you have a motor. Otherwise, the system will not run by itself. This one a motor, and the motor is not constructed together with the mechanism. So we just assuming that the motor will run with 100 RPM and transmit 100% via coupling. This one is coupling. Coupling. Okay. What else? The corresponding radii of rotation. Radii rotation is basically sometimes we call what? Eccentricity. Eccentricity are given here. RB, RE, RB, RC, and RD. So it simply means that if I can clear up this one, yeah. If you are viewing from one point, for example, here, if you are here, yeah, you can see this one, isn't it? Correct. So what does this RB? RB is basically, this is the center of rotation. This is R 0.3 centimeter. This C is 4 centimeter. And of course, for D, for example, it does not provide you D, but D here will be, where are you? D will be also 4 centimeter measured from here to here is 4 centimeter, yeah, 4 cm. Okay. If MB is 3 kg, they put it MB here. This one given 3 kg, and MC is 2 kg, 0.2 kg each. Sorry, 0.3 and 0.2 for B and C respectively. And the position is BC 90 degrees. This one, yeah, B and C is 90 degrees provided here. For complete balance, determine the position and magnitude of A and D. So the question asks us to define what is the A now and what is a D now. On the system, you add that one, and what will be the position? Position will be what will be the one place you want to put 0 degrees, 10 degrees, so on and so forth. Okay, so magnitude will be the value, what will be the MA and what will be the MD. So this is very, very, straightforward equation. Okay, I'm going to move to this one. Yeah. So let me move to the this one. Yeah. Your solution. Sorry. This one. I'm going to solve it two method, of course. One method will tell you about what? One method will tell you about the analytical. So look at your notes. You have the analytical here. You have the analytical here, and you also have the graphical. Let's start with analytical. So analytical meaning that. So for analytical, you remember this one. For analytical, the what this table, the table is an option. Is an option. For methods, this one compound, or must. Okay, remember that. Analytical, this table is on an option. You want to construct, you don't want to construct, it's up to you. But for table, it's a compulsory to tabulate all the data in form of table. Remember that. If you found that you solve it graphical and there is no table, so the lecturer who mark your work have to keep in mind that you have the intention to copy from your friend or to copy from any other source video. Okay, so there is why this one is compulsory for the graphical. Okay, now if I construct also table for both, for example, for analytical also graphicals, So you will have as such. I'm not going to, to explain how do you construct this one. You can do this one on your own. What I might be explaining here is, look at here, the mass, the radius, this is the m_r, this one is the d, distance from plane to plane, this one is the moment when you multiply by the position. Okay, why I select A as a reference? This is the reference. Why we have a reference? Because we are talking about multi-plane. So why A suddenly become a reference? So you have the result here. I also explain here, yeah. So to ensure that you understand, so remember this one. You have two possibility of reference position. One will be A, the other one is D. The reason is why this one is unknown. The reason is why this one is unknown. So in conclusion, the reference plane is always taken at any plane which is with unknown parameter. This one A is unknown, B is unknown. You cannot take B and C as the reference plane, because as you put B and C, it will not help you in solving the problem. You can't solve the problem, even though you are using the analytical. Okay, so remember that. The reason is why we want to ensure that at that particular instant, when you select A as to be a reference, this one becoming 0. So you have only one unknown. When you have this unknown, you put it back here. Then you have another one unknown. So if you have this one also in terms of B, this one is 0. So you cannot solve because you have two unknowns. Then one is so logic, isn't it? Then you need to use the LSM, which is known in our topic, which is least square method or trial and error method, which is not in our solution. Remember that, yeah? Okay, enough for that. I'm going to say that A is to be your reference. You understand why A to be reference. You can also select D to be your reference. Now I have all this one. So if you look at very careful, you at least have 4 unknowns, which is MA, MD, this one theta A and theta D, the position of each. And then you start from this one. Yeah, you cannot if you start with this one, very difficult for you because you have 2 unknowns. Remember, when you have one equation, 2 unknown, very difficult. You start with moment. That is why we start with moment or couple. And this is our boundary condition saying that must be equal to 0 because you want to balance the system. Then you start resolving into x and y. Okay, then you start resolving into x and y, and I can say that if you follow my way of solution, you will not lost or you will not find any difficulties. Yeah. So look at here, the MRD, this one, yeah, cos theta A, yeah, so on and so forth. This one is 0. I purposely put this one 0, yeah. So then because you have 0 here, isn't it? Then you have then you have one equation. I'm going to solve this one. You can do this one on your own. Huh? Okay, this one for x, then you start calculating for y, for example. You will have another equation, isn't it? Then what you solve these two equations, you have the result of the position. So the result position as such. But remember, we measure this one, they provide you 0, 90. So you have to follow right from your seat from horizontal plane. What you've been calculating is this one. What you need to define is for this one you will have as such. You put it back in the equation, every theta d by this one, you'll be getting a result of 0.16. You have another method of solve this one by using analytical. So many methods by using analytical, as long as applying simultaneous equation. Then you start looking for the false equation. Same thing. When you have this one, when you have the position, you found that this one is known, this one also known. You now have only one unknown parameter. Use this one now. So the second, this one is first. Then you start doing the one. Solve as usual. We have equation 4 and 5. You put the MD, this one MD as this one to be the part of this answer. Finally, jump to the conclusion. You have the result of ME together with this direction This one and also this one. Okay, it's not very difficult, isn't it? But if you have so many blade, yeah, let's say 20 blade, then you found that your equation become longer, isn't it? Because you have 20 term of equation into x and y. You still have two equation, but the term of equation is so many, yeah, depending on how many mass you have. Because one term equation representing a mass. Okay, I'm going to give you an idea of solving by using graphicals. As usual, as I mentioned earlier, for graphical, this one is compulsory. This one, yeah, table, must, or compulsory. It is a must to construct a table. After construct table, then you start thinking of constructing MR or MRD, because you know that you will have the MR versus this one, or MRD versus this one. Two polygons, remember? But if you look at very careful from the column here, you find that you have two unknown. Constructing a polygon is impossible because you have two unknown, which cannot be a closed polygon. When constructing a polygon, you must have only one unknown. So this one is one unknown. Start with constructing couple. Start with constructing couple. This one equal to 0 mean to say that whatever polygon you're creating or constructing must be a closed polygon. Even though at the end of the day, the polygon is not a closed polygon, you have to force yourself to close the polygons. Yeah. Okay, I left one point. This one. Yeah. Sorry, class. I left one point. I did left here this one just now. It's not one point. I left one information regarding how do you create the D. Okay, if supposedly I'm selecting A as a reference, D is a distance, yeah. So this one is reference. So I did mention that everyone will refer to A. So meaning to say that your RB will be 8. Look at here, RB is 8. This one is you have RC equal to 14. This one is 14. You have the RD will be 14 plus 7, 21. And all are positive, because you are saying that every mass on your right hand side is positive. You can also put this negative, it's up to you. If you want to put negative, it doesn't matter. But when you come to have a reference plane in the middle, then you have two-sided, which will give you one positive, the other one negative. If you have only one-sided, it's up to you to decide. Either you look at the positive and negatives. So here in my solution, I'm saying that a very common one is all positive, which is very, very easy to understand. So then you start construct. It's not very difficult, isn't it? So look at here. Okay, starting point. Then you have 7.2, 180. 7.2, 180 here. Then you have 11.2, 90 degrees going up, and it is not in scale. But this one, as long as you have you must have you must be good in creativity, because if you have two line, there must be a polygon. Polygon meaning that you can solve by using cosine, sine, or Pythagoras theorem. But if you have four line, very difficult for you to construct to use the sine or cosine. So this one have two line because only two unknowns in it. So you have this one. You close the polygon. You measure, equate with 84 md. This one you can measure. This one can be measured, or you can also calculate it. Isn't it? You can also calculate it, isn't it? By using square this one, by using Pythagoras. This one square this one, you get the same numbers. If you look at the numbers, it's very funny, isn't it? By measuring, you have 13.31, very, very accurate. No, it is not basically. You might be getting 13.4, 13.5, it's up to you. So the numbers you'll be getting depending on how much, what you call it, Parkinson disease affect you. You know Parkinson disease? Your hands still start rattling when you do something, typically in the exam on the test, isn't it? Because you are facing the nervousness. So this one we have the what you call it, the factor beyond 15%, it will be deducted. marks, yeah, or exceeded 15%, you'll be deducted mark. So you'll be getting 13.31 because due to the calculation. Then you start equating with this one. With 84, you'll be getting the results. This one known, you measure. Where you measure. This one measure at tail. Measure tail. If you measure the head, is it correct? But you have to multiply, sorry, you have to minus by 180. Huh? Okay. You measure the tail, or you have to minus by 360, depend on where the position is. Huh? You measure the tail, you measure here. That will give you 302.74. Again, it is not a result. This one is computed from the analytical. Analytical. In graphical, you might be getting 304 or 302 or 301. Okay. And you have this one, then the data now become the unknown parameter now become less. This one only the unknown parameter. Then you can start constructing another polygon. Constructing the false polygon. Constructing the false polygon is not very difficult. Look at here. This one you cannot do anything about it. This one yet 0.9 180. Okay, this is my starting point. 180. Why 180 go to left? Because following this one, the given parameter. The next one is 0.8, 90 degrees going up. Then we have 64 by this one. You measure and this one. And you cannot use any equation, cosine, sine, or even particle. So you cannot use this one. What you do, what you have to do is you close the polygon by complying the boundary condition. Then you measure this one. This one is by measure. You measure, you be getting this one, then you equate this one. That will have you this one. So if this is not very careful, this one. Supposingly, this is why you have to attend the lecture, because sometimes the additional information may be in the lecture, not only in the book. Yeah. So supposingly, after constructing the polygon, you'll be getting something like this one, for example. Yeah. This one is correct. Okay, correct. Very nice polygon. This one also correct. You go up here. Zap. Also nice polygon. And suddenly the last line will fall exactly at the starting point. So what does this mean? What does this mean? So if this one, so what does it mean? Could anyone tell me? What does it mean? Anyone? If you don't want to answer this one, I will leave it like that and you have to think about it on your own.
Resulted for E and
It is balanced.
Tan say it unbalanced. So when the last line is basically go to the starting point, what does it mean? Any other equation? Any other equation? Any other answer? Yes, class.
The total moment is balanced.
The what?
The whole thing is balanced.
Okay, then therefore
Therefore,
total force.
the starting
balance. I agree. Therefore put it here. Therefore what? MA equal to
Zero.
MA equal to MD.
MA equal to 0. So you don't have to put anything on A because it's automatically balanced on its own. Correct? Yes or no? Okay, so you have to be very careful with that. Yeah, sometimes it happens. If you are very fortunate, the last line will be closed by itself, so there is no mass to be adjusted or no mass to be added to the system, or we call it as totally balanced. Okay. 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 We move to the example number 2 now. Inshallah, we can complete this one. Then the next meeting, we're going to move on balancing that. We'll start doing these, what do you call it? These problems. Yeah. Before that, of course, as I mentioned earlier, you will have a tutorial session, and the tutorial session will be, if not a daytime, maybe a nighttime, and also together with that also what you call it, a mock, or a mock test before the actual test. And the mock test is not compulsory, but attending is not compulsory, but submitting is compulsory. Two different things. Yeah, you don't want to attend the mock test, doesn't matter, but no, submitting is compulsory. You might have some other thing to do, or you might doing your, or you might, happy to study on your own. Okay, anyway, we come to example number 2 here. You can turn to page 96, and if you look at very careful, this example number 2 is not different from what you have earlier. Look at the parameter. Excuse me. So you have the figure show it run with the speed of 1000 rpm constantly. It carries MA, MB, MC, and MD. The corresponding radii is given MA, RB, RC, and also RD. MA and MD are given. Now this time around is MA and MD are given. So this one is now unknown. This one is unknown. And they also provide you that the position between this method between A and D are also provided in here. Okay, so this is center rotation. So you found that the AD here is given as 0.15. This one you have A is 0.1, for example. So these are the equation you have. So I'm going to solve by using, if you read the notes video, yeah, you found that I also explain you can measure, or you can also, measuring, or you can also doing by calculating by using Particles theorem. Okay, run through your book, inshallah, will help you a lot. This is not basically a good book because because every step of calculation are written well. If you look at other books, it will not be providing you as such information. This one purposely for students to study. It's not for any other objective. For the student to study. That's why I provide you so many alternative solution. Okay, go back to this one. One more thing before I move to this one. If you go back and you construct your own polygon, you construct your own polygon, of course, with scale, this one. You will not be getting this graph, so you will not getting the same polygon. Remember this. The reason is why this one is drawn freehand without scale. You'll be getting the same, inshallah the same result, but not the same polygon. You understand what I mean? Because this one been drawn in freehand. So do not measure this one. That is why I do right here in my solution. Put it here. All polygon drawn are without scale. Okay. So you do not measure this one. This one is all without. It's a freehand, construction of polygons. But inshallah, the result will give you same. So in here again, when I say that this one is known, this one is known, the unknown parameter is this one unknown, this one is unknown. You have two possibilities of selecting the unknown, the reference. So let's assume you take B as a reference. So everyone refer to B, isn't it? And you have two-sided, so one will give you positive, the other one will give you negative. So that is the idea of example number 2. It's nothing more, just to say that if you have a reference plane between the masses, you will have both sided, positive and negative. If you're only a single-sided, you can have all positive, or you can have all negative. So that is the only reason, or the only different from example number 1. Look at here. I'm saying that this one B is reference. So you have B becomes 0. B becomes 0. So you have this one negative. You have all this one positive. So that is the only difference compared to example number 1. And I believe that it is you can do this one, and I trust you that you can do this one on your own, because the only thing that keep changing is the negative and positive. But in calculation, yeah, remember this one, in calculation, or in your analytical, negative is what, so showing you that it is not pointing that way, be pointing the other way. Okay, but in graphical, negative will show you, it's not constructed that way, you're constructing the other way. This one is positive, this one is negative. Okay, so that is the difference. So I'm not going to do this one, and the whole thing, what I intend to share is, just glance to the results. Get here, isn't it? You construct this one, you have this one as usual. Then you have a negative here. Look at here. Look at here, as I mentioned earlier. This one you don't have. Start with this one. Start with this one, yeah, class. Look at here. 0.750 degrees. Where does your 0 degree fall? Here, isn't it? What you have is 0.75. What you have? Negative. So it's always what? It's always opposite from the given direction. That is what I'm trying to say just now. Do you understand me? The rest, this one is 1.2 going up because positive. The last line is close. You can use measurement, or you can use particle statement. Okay, same thing for this one. Look at here. This one is the MR, 1.50 degrees. Okay, 1.50 degrees. Following this one. Then you have what you have 1.2 90 degrees, 1.2. This one 1.50 degrees, 1.2 90 degrees. So this one is 90 degrees. Next, 284, 2.84, 302.7. This one you measure 302. You have another line. Isn't it? Then you close the polygon. You close the polygon. This one you cannot calculate. You need to measure. You need to measure. Unless you know what be this one and what be this one, you can use Pythagoras theorem. Okay. Example number 3. And also I'm going to look for the forces. Number 1 and 2. Look at there. Talking about adjustment just now. Adjustment. You have to adjust M, whether M positive or M negative. Then you have to adjust R, isn't it? Then you have to adjust D, for example. This one is radius. So example number 3 will this one example number 1 and number 2. Example number 3 is basically what will be the D here. Example, this one you can look at if you go to your notes here. I'll be checking your notes here, and then if I can read very careful, very fast here, you have where are you? I forget the numbers. 1 minute, yeah, 1 minute class. I need to share with you this one because later on you have to do this one on your own. 1 minute, 1 minute. Where are you? This thing when you really need it, will not here. When you didn't not need it, it's always here. Easy to catch. This one. Where are you exactly? Can you what is the position of this? Can you the position of maximum? Can you check on your note talking about the radius? I want you to know how the another adjustment for the radius. Yeah. At the moment, I fail to catch what number is that. Anyone? Never mind. When I get it right, I will tell you. I will inform. Or perhaps number 4. Look at number 4. Number 4. Number 4. Number 4. Number 4. Huh? Number 4 will be number 4. Look at the number 4. Look at here. At this condition, calculate the radius of eccentricity. This is another example when you want to adjust the radius of basically radius of eccentricity is same as radius of rotation. Okay, so that will be the answer. So this is another example which is not provided in your notes. Yeah, you can do this on your own on the tutorial session later on. Okay, go back to this one. When you completed everything and put it in the table, you found that this one is this is the beauty thing of the solution. Look at here. This is the polygon forces. This is the polygon of the the couple. You can construct force, or you can also construct this one because we have only one unknown. It's not only one unknown, isn't it? So you can use either one. The previous one you cannot. You have to start with couple because only one unknown. Just remember, you want to construct polygon, must be one unknown. You want to solve the equation, must be one unknown. Okay, so you have this one. Okay, you do another time. Let's say that you do this one. Yeah, following this one, you have 90. Again, this one. Look at the negative 90. Negative 90. So where is negative 90? The negative 90 is 90 will be pointing upward. The negative will be pointing downward, be due to the negative. Then you have 97.5, 0 degrees, it moves toward your right. And again, it is not polygon, a closed polygon. You close the polygon and you can solve this one by using particle theorem or measuring the last line. You'll be getting this one, equate from what you have, then you will have x. You put x here, then you everything solve. Huh? You do another one. Look at here, 225 to 90. 225, 90 with pointing upward, 225 pointing upward. Then 195 pointing toward your right. Then we have 132 pointing this one. And then it's not closed polygon, you close the polygon. Then you measure this one. This one you have to measure. You'll be getting a result of 9.16 kilogram at the position of, when you measure, you have 252.5. This one. Okay, any question? So when I meet you again, inshallah, I'm going to explain to you what is the dynamic force on bearing. So this is the next week or the coming week lecture on topic on dynamic force on bearing. So before we close the session, I would like to again, highlight the thing that we studied today. One will be you are basically talking about the adjustment. It's one adjustment that you are basically looking all these parameters, the M parameter, the mass, the radius parameter, and also the d parameter. Okay. The other one will be the one. The other one will be the forces, which will be explained later on. And this one we have so many forces. Okay. So what are the method? The method is analytical. Remember, analytical, and the other one is graphical. So which method is easy? It depends. To me, student must know both, but mastering one. You get what I mean. You must know both, but mastering one. You must know analytical and also graphical. But you mastering meaning that you can easily solve this one conveniently and confidently. So some of you might be thinking using analytical is good, so go ahead. No, inshallah, you can also good in graphical. But some of you might not be thinking simultaneous equation is so bad for you. Start doing graphical and start practicing with graphical. But you also need to know analytical because most of practical exercise is using analytical. Graphical will not be used in practicals. Okay. So with that, I think I would like to end my session with open Q&A if there is any question from floors.